So welcome for the again for the Circular Society Lunch and Learn meeting about decision support tools for a circular society. I will share, for those who are not familiar yet with Circular Society and the EWUU Alliance, I will give a very short introduction about us and about what we do before giving the floor to our speakers, Negin Salimi and Chihan. So the Institute for Circular Society is part of the EWUU Alliance. You can see in this picture an overview of all the institutes and working groups of the EWUU Alliance. And Circular Society is one of them, next to Institute for Preventive Health, and the Center of Unusual Collaborations is also an important partner, as well as education, living technologies, and artificial intelligence. So this is the EWUU Alliance. The Institute for a Circular Society has two main topics, urban-rural circularity and circular safe hospitals. That's what we focus on. And what we do is we support researchers to develop new projects in these research fields that you see on the slides. And we have seed funding available for this, and we also support them to go for external funding. And one of our, well, not one of, but the most important supporting topic or enabler for both urban-rural circularity and circular safe hospital is digital innovations. Shihan is scientific coordinator of this team, and well, she will be one of the speakers today. So we are focusing, well, on CS Digital and on decision support tools today. So I would love to give the floor to Chihan and Negin Salimi to enlighten us about decision support tools for a circular society. Chi, can you take control? Yes.
Good afternoon, everyone, and thank you for joining us for today's Lunch and Learn session. My name is Chihan from TU Eindhoven, and I'm here with my colleague Negin Salimi from Wageningen University and Research. Together, we will explore role and added value of decision support tools, including methods like digital twinning and multi-criteria decision making in supporting the transition towards a circular society. Negin, please introduce yourself.
Yeah, thank you so much, Chi. Hello, everybody. I'm Negin Salimi, assistant professor at Wageningen University, and my research field is in sustainable entrepreneurship and decision-making. So more specifically, I help and guide entrepreneurs to make more informed and structured decisions, because you know that sustainability transition is really challenging process. So and entrepreneurs need to make more structured decisions. Yeah, that's a short introduction about me. Thank you for having me today.
Yeah, I will also briefly introduce my research interests. My research focused on how does the data-driven technologies add value to provide informed decision support for the efficient use of available resources, and also how can the sustainable transition process be organized strategically with the new insight from emerging data. Today, we will start with acknowledge the complexity of sustainability transition. These are not simple problems, but they are long-lasting problems, challenges, systematic challenges involving a wide range of stakeholders, governments, business, researchers, civil society, and everyday citizens. Each group of the stakeholder brings its own perspectives, interests, and ways of communication. That's why co-creation is essential. Without it, we risk fragmented efforts. Transitions take time, and they require a shared sense of ownership and a collective vision. These transitions play out in what we call multi-actor ecosystems. They are dynamic, open-ended, and value-driven. To make progress in such settings, we need flexible approaches that empower diverse actors and facilitate learning and shared understanding. That is where the key enabling methodologies or KEMS come into play. These are the tools and the frameworks that support system thinking, coordination, and pluralistic value creation across stakeholders. In such complex systems, structured decision-making becomes critical. That's the role of decision support system, or we call it DSS, comes in. These are the tools that help integrate data, expert knowledge, and the models to compare options, conduct scenario analysis, incorporate stakeholder inputs. Importantly, DSS tools don't make decisions for us. They support better decisions. When combined with the digital training, creating a digital replicate of the physical system, we gain real-time insights that allow for faster and more accurate response. Decision support tools can take many forms. They can be model-driven, data-driven, manual, hybrid, or spatial-oriented using GIS. They support different types of analytics, from descriptive and diagnostic to predictive and prescriptive. What's exciting is how these tools are being used to support challenges like spatial planning, circular construction, earlier stage design, and policy development. We have been outputs such as GIS tools, LCA2 models, and interactive web platforms. Stakeholders using it range from municipalities, NGOs, to architects and manufacturers. The common goal of all this is to help people to make better and more informed decisions. We recently conducted a survey among the EWUU researchers about their experience with decision support tools. The results show a growing interest, but also important challenges. Many of the tools are still too complex or poorly integrated. Users cite issues like lower usability, data access problems, and unclear definition of circularity. But we also see a positive patterns, especially when tools are co-created with users, customized to specific roles, and intuitive to use in the real time. Next, I will give the floor to Negin to further introduce the topic.
Yes, thank you so much, Ji. So the result of survey that showed that many of these problems that we found are related to the decision problem. That was really interesting. And this is why today I want to explain about multi-criteria decision-making method and how we can relate that problems in special sustainability context to multi-criteria decision-making. So what is multi-criteria decision-making? It is a process that every day you use it and you throw it many times. So it is a cognitive process when you want to select an alternative or even rank or sort alternative from a set of alternatives. And in the case of the survey that we did, we found that there are many stakeholders involved with normally conflicting interests and objectives, and there is trade-off among these decisions. So it's not easy, and these trade-offs make the decision very complex. And at the end also, we have different stakeholders, and the question is how we can integrate all these different perspective in the decisions. Then we give this feeling that, hey, we consider all your perspectives. So this is the place that MCDM can be helpful. So I want to explain these parts or this and highlight how MCDM can be helpful. So let me simplify the process of multi-criteria decision making. When we are talking about multi-criteria decision making, it means that we have some alternatives and we have to evaluate that alternatives based on some criteria. So, for example, if you want to buy a car, so you have some options, of course, and you have, for example, maybe for you price, quality, safety, or relevant criteria. But for you, these criteria has different importance or weights than, for example, the other one that wants to buy a car. So this is really important to consider these differences. So the first step in multi-criteria decision making is to identify the problem, because sometimes, actually many times, we don't know even what is the problem. So we have to identify or understand the context of the problem. So we have to understand what is the goals, what is the constraints, what are the potential and stakeholders who are involved, and and there are different methods we can do that. I'm sorry, just I have, yes, yeah. So one of the method for the structuring the problem, some of them are cognitive maps, scenario planning, and mind map. And when you structure a problem in a different way, the outcomes are different. So it is really important to structure how you structure your problem. The next step, when we structure the problem, we have to build a model. So here we have to identify the potential alternatives, also the criteria. And here in decision making, we don't say collecting data, because here you make decision based on your preference. And this is the role of analyst, to elicit the value from your mind. So we have value elicitation. And we have different methods for this. Some of them are value-based method, like analytical hierarchy process, that we call it AHP, best worst method, multi-attribute theory, that normally I'm using this method in my research. And also we have outranking methods that I don't want to go into this method. And when we build our model, now we have to challenge our model. We have to check how much our findings or our model is robust. If, for example, we enter new criteria, because, situation is always changing. So maybe we have new alternatives. So we have to see how much our findings and our results are robust. So we have to do sensitivity analysis. And then finally, based on our findings, we have to develop an action plan. And if you see, in each step, we have a feedback loop, which is really important. Okay, so let me back you to the real question that we found from stakeholders of bio-based building field. So here I put 5 main questions, real question or real problem that they have. For example, let's look at the first one. Which fiber crops are most suitable for different areas, or what instruments should municipalities use to stimulate fiber cultivation? So at first glance, maybe you see that, oh, this is a operational or policy problems, but honestly, these are decision-making problems. So I want to explain for you and do step by step a process of one of the famous multi-criteria decision making to solve the first problem, which fiber crops are most suitable for different areas. Okay, as I mentioned, the first step is to structure our problems. So we have to identify the decision context, who are our relevant stakeholders, that can be those who make decision or who are affected by or implement decisions. And we have to make decision if we want to, how, and if we want to involve them, and how we have to involve them. And of course, there are different methods to do a problem structuring method. That's here you see the different methods like cognitive maps that, it's really a personal decision, but personally, I really like cognitive map, and this is what I do in my research. So what it says that, okay, when you have different stakeholders with different perspectives and objectives, first you have to go and talk with them, with, for example, the first stakeholder group, and just tell them or give them the problem. The problem here that we want to discuss and go in detail today is selecting the most suitable fiber crop area. And then just let the stakeholders do thinking about, okay, what is the problem? What are the main criteria, or what are the underlying assumption based on the factors, and just and you as an analyst, you have to find this relationship. And normally in the cognitive map, in the head of the map, we have the objective. So objective is clear. We want to select the most suitable fiber crop for area. And then based on what the information that stakeholder gives to you as an analyst, you have to find the possible alternatives and also make the links based on the statements and find the criteria. Okay, it is not an easy job, honestly, because especially when we have different stakeholders with different objectives, you have to go and have the cognitive map for each group, and then it is your role to integrate all these different cognitive map, and at the end have one cognitive map. Or maybe you can just sit with all the stakeholders together and see what will happen. But it is really challenging, and we normally in the literature it's advised to have separate cognitive map and at the end to integrate them. Okay, so when we do the problem structuring, so it means that the problem is clear, and let's say this is a hypothetical example. So for example, let's say based on what we found from the stakeholders or experts, we come to these 6 criteria: water usage, yield per hectare. So these are our criteria, okay, for now. And we have also 3 alternatives. This is all it's a hypothetical example, so you can go for other criteria or other alternatives. It's really dependent to the how you structure the problem and how and also the stakeholders you want to involve. So it's not my field about different alternatives for actually area for fiber crop, but let's say hemp, for example. I don't know you know about this, but maybe Chi knows better than me. But hemp is a fast growing crop with strong fibers, and it has a good CO2 absorption. And the other one, yes, this is flax, known for producing linen, and flax does well in temperate climates. And finally, the final alternative is miscanthus, a tall perennial grass often used for bioenergy. Okay, so now the problem is clear. We have our criteria and we have the alternatives. So, and see this table. Okay. We assume that decision support tools that she mentioned, we have different methods. So we assume that we can get these data or the data in this table from decision support tools. But what does it mean? It means that, for example, you see that in the first column, you see the alternatives, and each alternative has different performance based on all 6 criteria that you see in the first row that is in orange, okay? So, and as you see, some of them are real number. It means that for some criteria, we can simply go and look the documents or the information that is available and just extract that data and put it in the table. But for some, for example, here I put the climate adaptability. Sometimes for some criteria, you cannot simply go and read document and just extract that data. So here again, you need to extract this data from the mind of experts. So for example, here we have it number between 1 to 10. And also, for example, for soil regeneration. So again, we cannot, for example, in this case, we don't have access to the real number. So we use number from 1 to 9 that it's expert based. So we extract it from the expert mind, okay? So far, we have just a table full of number, but decision making cannot be done just simply by looking at this data and these numbers. So honestly, decision making is based on the value that we assign to each of these alternatives based on different criteria. And here, this is the place that we have to use one of the methods of MCDM. Okay, so here today I want to use best worst method, which is developed recently developed in 2015 by a full professor at TU Delft, and it is one of the famous one. And why? Because MCDM is normally based on pairwise comparison, and you have to do many pairwise comparison. And our mind is limited, honestly. And if research shows that if we compare more than 9 items, so the consistency ratio decreases. But this method that I will show you here, yes, yeah, this method starts from the best criteria and also the worst criteria. So as an analyst, for example, when I want to elicitate the value, I first ask my decision maker, for example, okay, to select the best criteria and compare the best criteria over the other criteria. And again, I ask which one is the least important one, and ask him or her to compare other criteria over the least important one. So already you have the 2 reference point, and then for mind having comparison, it's really easier, and you can increase the consistency level. And also this method can tackle many biases like anchoring bias, and that I don't want to go in detail, but this method consider these biases also in the model, and then the solution is by considering mitigation strategy. And then there is a minimax problem. So I don't go to the mathematics and the formula behind that. So just I want to that this is optimization problem. Okay, so now you see here the normalized table of the one that I showed you, the performance table. So why we have to normalize our performance table? So what does it mean? Because, you know, if we want to provide a base to compare each alternative based on these different criteria, we have to find the value that decision maker assign to each criteria in terms of different criteria. So we have to transfer our data to numbers from 0 to 1. There are different methods for doing that. If our data is linear, if we assume that our data is linear, we use the simple formula for normalizing that you see here, that I use this one. But if your data is not linear, there are many other methods. So now we have to find, when we normalize our performance table, then we have to find the value of each alternative. How we have to do it? So now I stop the presentation because I need to share a slide, the Excel file with you. So then it's easier because it is an interactive activity now to make it more interesting and feasible for you. It's loading. Yes. Can you see it?
No, for me, it's still loading, Negin.
Oh, now
So there's 9 minutes in total left for the
Yes.
presentations. So.
Okay. So now?
No.
No? Oh, let me. So it's. Okay, I think I found a solution. Okay. Okay, I think now you see my screen, yes?
Yes.
Okay, perfect.
Great.
So this is the Excel file that just I want to simplify the process. Okay, now we have 6 criteria and also we have Chi as a decision maker. So I'm the analyst now. We have we play this role, and okay, Chi, can you can you tell me from your perspective which of these 6 criteria is the most important one for selecting the most suitable fiber crop area?
I think price is always very sensible for the stakeholders. So price will be the best or say
Yes,
most
thank
important.
you so much. Yes, and the least one, can you tell me which one is the least
Maybe
important?
soil regeneration is less visible.
Yes, okay, so I put this. And now I want you to compare the most criteria over the least criteria, use number, as you see it in the right side of window, use number from 1 to 9. 1 means equal importance, but 2 somewhat between equal and moderate, and just go to 9, absolutely more important, okay? So can you tell me what is the importance of, sorry?
This one will be 3.
3. Okay.
Yes.
So price is. Are you sure that 3? So because
and which one you want me to evaluate?
Yeah, the most important one, which is price per ton.
The most important one, of course, is 9.
9. Okay, thank you so much. So. Okay, because first we have to compare best to others. So it is really simple that to compare best to others. Okay, and okay, can you tell me now? This one is 1. Okay, can you now compare the best one price over the yield per hectare and give me a number?
I think it's moderate 3.
3. Okay, and if you compare the best criteria over water usage?
5 strong.
5. Okay, and with the third one?
6 somewhat between
6.
strong
Okay,
and very strong.
And carbon sequestration, if you compare best
7.
to this one? 7. Okay, so thank you so much. And now we go to the comparison of others to the worst. So so here the worst was 1, and I can already fill in this part because I know this, so it is not necessary to ask again from the decision maker. So can you also compare yield per hectare over the worst one, which was soil, and give me a number?
I will say 2.
Okay, 2. And water usage over soil regeneration, can you give me a
5.
number? 5. Thank you. And climate adaptability over the worst one?
6.
6, okay. And then carbon sequestration over the worst one?
4.
4, okay. So
Negin?
here, yes.
A question from the audience is, should the price not be 9 in column G? I think in the because that was the best one.
Yeah.
I think we switched now regeneration, soil regeneration and the price.
No. Here we compare best to other, best to best. Here we compare best to best, so it's one equal. So and then we have to come to solver and then solve it. And here, yes, and here you see that we have the weights here. So and okay, so because we didn't have so much time, the pair comparison here, it's not consistent. So we have to do it again with Chi, but that's fine because of the time limitation. We couldn't have it with the concrete, with the precise focus. So no problem. So now we have the weight, okay, and now based on the weight, we can calculate the value of each alternative. So here you can see the normalized version of our performance table, as you see here. So now, for example, the value of alternative A1 or hemp is the function of value of that alternative in terms of criteria 1 plus the value of alternative A in terms of criteria 2 and until the end. And at the end, here you see that we have the overall value of each alternative, and you see that the rank, the first one that has the most suitable one for our problem is the first alternative because its value is the highest one. So this is how it works. So now I go back to I stop sharing. So
I will share again.
Yes, thank you.
Presentation.
So this is the simple version of best worst method. It is the linear one, but of course we have many other types.
It's taking a while.
Yeah, no problem. I can talk. So the linear one, the one that I used, yes. Okay, I take control.
Yeah.
Let me go to this one. Okay, so yes. So the linear one is the deterministic model. It means that we find just one solution, but we have also non-linear version that we have multiple solution. It is really good when we have different stakeholders with different perspective. And the other one is parsimonious best worst methods. You can imagine that we have some cases that we have many alternatives and many criteria. So here the decision maker start with the evaluation of set of subset, and then you do your assessment, and then you use the same mechanism to the other subset. And another one is non-additive. Normally, we assume that there is not any relation or overlap among the criteria, but you see that in the reality we have, for example, normally when we have a high price, it is a sign of high quality. So this is also a method, non-additive, to consider also this interdependency among the criteria. The other one is belief-based best worst method. So sometimes for decision maker, it's really difficult to talk about their preference. They cannot do the comparison. So here we rely on their belief. And finally, we have Bayesian best worst method that here actually when there is uncertainty involved in our decision, so we have probability. So it's really important to check first which method, best worst method, is usable. One thing, this is my last slide, is that the beauty of MCDM is that we know that we don't assume that we know all the criteria or all the alternatives, which is normally this is the assumption of normative model, and or even descriptive model that just show us, hey, there are some limitations. There are in the mind, for example, we don't have complete information and we cannot do rational decision. But what perspective decision model like MCDM and the best first method do that we consider all these limitations and we enter them in the model, and at the end we so we don't prescriptive decision model. It's not about how we should decide, which is the what normative model do, or it's not how we do decide, but it's how we can decide better by considering all the different perspective trade-offs. This is the beauty of MCDM. Thank you so much.
Now I will take over. Let's start with some takeaways for practitioners today, those designer building or using this decision support system in real-world practice. First, it's important to remember that the decision support tools do not make decisions for us. Their real value is in helping us clarify complex trade-offs so we can make informed, transparent decisions. Second, effective decision-making in multi-actor environments relies on collaboration and inclusiveness. We need tools that don't just compute, but communicate, enable diverse voice to be heard around the process. Third, while technology sophistication is important, it is often simple and co-designed tools that get adopted and actually be used. Complexity should serve clarity, not the other way around. Finally, digital tools like decision support system or digital twins must be tailored to context, to the stage of the project, the need of the users, and the governance structures involved. A one-size-fits-all solution rarely works. Also, there are some takeaways, for the researchers and the policymakers. Now, some of the biggest priority is to invest in the key enabling methodologies or KEMS. These are the foundational tools and the practice that support long-term collaboration and learning across disciplines and sectors. Second, we need to move beyond the standalone tools. That's really needed are the platforms environments where data, dialogue, and experimentation can come together to support ongoing collaboration and feedbacks. Third, we must bridge technical models with lived experiences. A GIS map and optimization model is powerful, but it must be connected with how people actually live, decide, and adapt. And finally, systematic transitions are not linear. They require experimentation, feedback loops, and the courage to adapt. Policymaking must reflect this, enabling flexibility rather than lock into the rigid path. So the message today is build for reality, not just for theory. Thank you for listening. If you want to know more, please follow us using scan the code. And we may have one or two brief questions.
Yeah, so thank you very much, Negin and Chi. I really learned a lot, but let's give the floor to the audience and see if anyone has a question for either Negin or Chi. So please just ask if there's anything you want to know. Silence.
I see in the chat there is a question, how does one deal with interested stakeholders that give different weights to the criteria?
Yeah, that's a really good question. So of course here I did the practice with just one decision maker, but in reality we have many, so we have to aggregate. So let's say, for example, for a problem, we interview and elicitate this information from 20 or 30 decision makers, and at the end you have to aggregate the weights, and at the end, so then you give this feeling that, hey, we consider all the opinion of different stakeholders. I hope I answer your question. So in our Yok, I think she asked, in our course decision science too, we also discuss pitfalls, regression. What would your opinion on that? Yeah, sorry. I don't know exactly what do you mean.
Aggregation. Best worst method and compensation like methods like AHP, in which you can compensate bad behavior for one aspect with very good behavior on others. Do you also use other methods that don't have this specific behavior?
Yeah, indeed. Actually, in best worst method also we have the same rule actually, like what we have in AHP.
Yes, and that would be exactly what I would describe as a pitfall of AHP, that you can have compensating behavior. So do you also
yeah, I'm not saying this as a compensate behavior. Actually, I formulated as a compromise solution. So honestly, I don't think it is a pitfall. So if we want to involve all stakeholders, so at the end we cannot find the optimal solution. We have to satisfy ourselves with the suboptimal solution or compromise solution. This is so how best worst method works.
Mm-hmm. Yes, we would also tend to investigate non-compensational methods such as electroimpropriety, etc. Yep.
Yeah. Okay. Nice. Yeah. So I call the electroimpropriety as outranking method. So
definitely.
Yeah. Okay. Yes. Yeah. Okay. Okay. Nice. So I think one general question from Samir: how will AI play a part in circularity for the society? So maybe this is the part that she can respond.
Yeah, I just respond that we will develop another learn session, especially for that.
Yeah, I think you could talk hours about that one.
Yes. And we also invite more researchers who willing to contribute in this new learn session for AI, what the role of AI can play in the circular transition.
Yeah.
Yes.
Okay.
So Samir, I hope you feel invited to collaborate with us on this. And I see two more questions, and we're running out of time, so maybe
just Fritz, I will. Yeah, that's really nice. Please contact me. I think we will find some common fields to work with each other. So one question from Liu, I think. So how do you select the criteria? So yeah, indeed, it's really difficult. So we need to normally what I say to my students that we have two sources. First, from literature, so you have to find the criteria from the literature if there is enough study, and then you have to double check them with the expert or decision maker. So you have to be sure that you consider all the criteria, relevant criteria. Sometimes they add other criteria, or maybe they say that, okay, in this context, for example, in the Netherlands, we don't go for this criteria. Although you find it from the literature, that's fine, but in this context, we don't go to consider this. So this is how we do. Okay, yes, thank you. I think there is no other questions, but of course, feel free to contact us. And thank you so much for having me.
Yes, thank you very much, Negin, and also Chi, for presenting this interesting topic. We will close the meeting now. I hope everyone enjoyed it. Yeah, and please also share with your colleagues if you think this might be interesting for them, because we have recorded it and you can watch it on YouTube. So thanks again, and have a great day.
Yeah, thank you.
Thank you.
Bye.
Bye.